Do you have a 27 MHz AM CB that doesn't have much use? Maybe because, at least here in Australia, most of the people using CB for short distances have gone to UHF, and most of the serious enthusiasts use SSB. But an AM CB can still be useful for some things. In a previous video, I described how you could use a converter to up-convert shortwave signals to 27 MHz. Another option is to build a beat frequency oscillator, so you can tune in to SSB CBers on just an AM set like this. In this video, I'll describe one that I built. It's a very rough prototype, but as you'll hear, it works quite well. How is this achieved? The first thing is that I don't have a free-running oscillator on 27 MHz. Instead, it's on a lower frequency and is mixed up to 27. I do that by mixing it with a locally generated signal on 30 MHz. That's actually a harmonic of this 10 MHz crystal oscillator module. The VFO itself is under 3 MHz. That 3 MHz signal mixes with 30 MHz, which is one of the harmonics from the crystal oscillator module, in a diode mixer. Very simple, there's only a handful of parts involved. Anyway, one of its many outputs is 27 MHz, that being 30 minus 3. If I want to go higher, e.g. channel 40, which is 27.405 MHz, then I reduce the frequency of the local oscillator to around 2.6 MHz. I should mention that this BFO requires no internal connections to the CB radio. The main disadvantage is that unlike a BFO at the intermediate frequency, it may be 455 kHz, with this BFO it's on the signal frequency that you're tuned to. Therefore, when you change the channel on the CB, you also need to readjust the BFO. The oscillator module requires 5 volts. That's also a suitable voltage to run the BFO. The diode mixer is passive and doesn't need any supply amount. I get the power from 4 AA batteries. As rechargeables, they're 1.2 volts each, giving a total of 4.8 volts. Having a look at the circuit, the majority of parts are used in the 2.6 to 3 MHz VFO. I'm using a metal type 250 picofarad variable capacitor, though you could quite easily substitute a plastic type, though it may be slightly less stable. In parallel is 100 picofarad, and here is a 10 microhenry RF choke, which is the coil used for the tank circuit of the oscillator. The transistor used is a standard NPN small signal type. This is the 10 MHz oscillator module. You'll notice there's no tuned circuit after it, therefore its output will be quite dirty. There will be signals on 10, 20, 30, 40 and higher megahertz. That would be a problem if we're using it in a transmitter or a critical receiver application, but in this case it's okay.
A legal cross with a ditch. Or something like that. Hey, Rodney. Picture this morning of a mongoose radio AM. A mongoose? The mongoose radio AM. There's one in America's couple of bandwags. And what's anybody name? I can't think of his name here. Bundy, catch you later, Tom. Get out here, 173. so covered. Sounds all good budgies out there, 35 Charlie bag of noise maker on the side and listening there, guys.
So this is our quick look at a signal frequency BFO on 27 MHz. It allows you to receive SSB stations with just an ordinary AM CB radio. If you really wanted to confuse people, you could try calling SSB operators on AM. Provided your set's on frequency, they'll resolve your signal, but they'll be puzzled, given you're transmitting AM on an AM-only CB, how you're able to resolve their signals well and copy their transmissions. Heard a term on the air you don't understand the meaning of? That's where you need the Illustrated International Ham Radio Dictionary. Just released, it's available as an ebook and in some countries in paperback as well. For more information, visit my website VK3YE.com or search Ham Radio Dictionary on Amazon.